Hey folks, this set of days off started a little differently than previous weekends have. When I'm not at work or busy working on projects here at the shop, I have a little side gig that helps fund these hobbies. And what that side project is, I build RTC kits or return to center kits for rear steer applications. And the best way to really explain what that is and how it works is to just show you. So I'll take you in on this project. Actually runs my own system. So I'll take you back and show you the whole system in this truck, and then show you what I go through to build these kits for other people. Much like any typical full hydro front steer setup, your rear steer is going to consist of a steer axle, a hydraulic cylinder, a pump to make volume and pressure, and a valve to control it. That would be your biggest difference between front steer and rear steer. Front steer, you're going to have an orbital valve or an HMU, hand metering unit, that your steering wheel connects to, and that's going to control the front steer. Rear steer, your control valve, there's a couple of different options there. I'll take it over to the bench and show you what those are. Now this first example is one that a lot of people would probably consider the cheapest, quickest option. And that's just a full manual spool valve. Really easy to plumb in, super simple the way it works. Two directions. You plumb it into, one direction is going to turn you right, one's going to turn you left. So that's the bare bones minimum. My opinion, it doesn't matter how good a driver you think you are, that thing is going to humble you really quickly. Now the next option. This is a solenoid valve. So it's basically doing the same thing. It's diverting fluid left to right, except for it's doing it with electrical input. These solenoids are shuttling that spool back and forth. So that's what you're controlling. This particular valve here this is a huge valve. This is not something you'd probably use on a normal rig. I'm just using it for visual reference. So those are two different options on those valves. Now this one here, yeah, you probably have a little bit of control where you can regulate that flow a bit, where this one here is full on, full off as soon as you flip the switch or push the button, however you're controlling it. But once you get used to it, you can actually kind of flutter that button or like basically pulsate it and control the steering pretty good, in all honesty, once you get a feel for it. However, with the rear steer or return to center kit like I build, you have to have electric solenoid valve, and I'll show you why. Now the reason you need that electric solenoid valve is because you're basically taking a mechanical input and turning it into an electric signal, for the most part. Here you can see I have a control cable that's attached to this high steer arm, so anytime the rear tires or this knuckle turns, it extends or plunges that cable back and forth. Right here it's in the centered position. This cable comes along, it runs up that link bar, on up into the cab. Once it gets beyond this front pivot, this front frame mount on the link bar, comes up right through here, if I can get it, and goes into the floor of the cab. From there, the cable goes to that sensing unit that's clamped to that tube there. So this is where you're converting that mechanical input to an electric signal. The cable is hooked to that rod, which goes in that body, and it has a plunger on it. That plunger in a center position sits between those two ball switches. So anytime the rear tires are turned one direction or the other, one of those two ball switches is depressed, closing a circuit. Now for controlling my rear steer, it's actually a Genie scissor lift controller on my shifter here. So my right hand is always on the shifter. I can turn right and left with this rocker switch up here. And then my return to center button is this red button here. So I can turn right, turn left, and then I can push and hold this button until it returns to center. Once the rear tires are centered, it stops automatically. Now this particular system I actually have wired up for two modes. This center switch, centered is off. One way is the mode I just described, where you have full control, this right, left. You let off this button, the tires stay right where they're at until you push and hold this button and it goes back to center. You flip this switch the other way and it has what I call auto center. So you can still turn right and left as much as you want, but as soon as you let off that button, the tires automatically go back to center. A lot quicker for a racing application. I think a lot of monster trucks run similar setups. So yeah, combine those inputs with those inputs, along with a harness and a little box full of relays and diodes, and makes for actually a really pretty simple system. Now this particular truck here is running a 12 volt electric pump. So that's a 12 volt motor running that pump in that body, and that's the reservoir. I have it mounted in the cab, mostly for cleanliness and lack of real estate about anywhere else. I'll show you how this system works. I don't know how it'll be, if it'll be too noisy with that pump in the cab and whatnot, but you can see we'll switch. I think this is auto mode here. See how that works. Do the exact same thing, only you can see the tires. Now if you put it in more of the manual return to center mode, that's how you make yourself look like you can drive with rear steer. With the basics of the rear steer system covered, now we'll look into the actual sensing unit. This is probably the most important part of return to center, in my opinion. So these are the parts that I build for people to set up with their rear steer system. Now this is assuming that you already have a working rear steer system in place. Maybe need to upgrade from a manual valve to a solenoid valve. But either way, this is the core part of the kit. So these sensing units start out as a chunk of 1 5/8 60/61 extruded aluminum bar. They're cut into 6-inch long blanks. And from there, they go in the lathe and they're turned down on this end here. This is the mounting surface. So each end is turned back 1 inch down to 1.5 inch diameter. And while it's in the lathe, so it's in the lathe in the chuck like this, you turn this diameter down here, and then I'll bore this internal bore here to just under 1/2 inch. Then it gets flipped over, same thing. Cut this end, bore this end, till the bit goes through the other side. So now it's drilled all the way through. The next step is providing a place for the ball switches. Now this depth is really pretty important. That depth is actually what sets that ball switch in its location and relevance to the plunger in here. So if they're too deep and that plunger is too long, it's going to be trying to depress one switch or the other no matter what. So I used to actually do these in the Bridgeport manually, and I've gone through different tooling like this homemade fly cutter here to create that flat surface. Eventually I splurged and bought an end mill, the right diameter for it. But now I have this fixture that I can set up on the Shapeoko 5 Pro CNC router table. So this is set up, the machine's dialed into, located on this plate, this fixture here. And then I can quickly, drop them in. Got this pretty simple clamping setup. Got one in this end, one in the other end. Now that Shapeoko can come in here and machine this flat here to the proper depth and this bore and have it ready for tapping the threads in it. Once that's done, then it goes back on the Bridgeport. I still have to manually tap them, so I go in, I guess, not really technically manually tapping if you're using a Bridgeport to tap it, but I go in, chamfer the hole, and then I tap it to a set depth with that all on the Bridgeport. The cool thing is now I can set one of these up on the CNC table, and in the amount of time it takes to cut these two surfaces here and bore these two holes, I can have the one that just came off the table on the Bridgeport, chamfered, tapped. Then they go in the lathe again, and they have a 5/1000 over ½ inch reamer, and I run that through the whole bore. That deburrs this hole and takes that bore to a 5/1000 over size for this plunger. And this plunger here is just basically a nylon spacer. It's already got the right bore to run a 1/4 inch tapped on it. And I've got this rod here for the plunger threads onto that rod. This is what an assembled rod looks like. Now, with the body's done and the plunger's done, on to mounting. For these mounting surfaces, I start out with these clamps that are actually, I have a local guy that cuts those out on a water jet table for me out of stainless steel. And then I cut a bunch of 1/2 inch, 1/4 inch ID sleeves at the right length. That's a blem because it got messed up. Then they're TIG welded on here. And after welding, then they are split. I have a little 4-inch grinder with a zip disc. It's set up kind of like a table saw, so I can just run them through it. Now you have a split bolt clamp set up. Slides on there. Usually you have to use a wedge or a screwdriver to open it up to fit it on there. So now you've got clamps, you got the plunger, you got the bodies, you thread the ball switches in it, and then you have this assembly right here. Now these clamps double as a mount. You can see the bottom is flat here. So if you have a flat panel you can bolt this to, you just drill 2 holes there, utilize these nuts to both clamp the body in place and mount it. The second job for this piece is for the control cable. So your control cable comes through, your bulkhead nuts hold it in place on this side, passes through here, and then the actual control cable portion attaches to the plunger there. So it pushes it in and out. And they're super universal. So you can actually rotate these in the clamp, where if you might want the switches up here, depending on how you have it mounted, or you can actually switch the plunger to the other side of the unit. Just whatever a guy needs. So there you go. That's what I did my first day off, was get another batch of 10 of those assembled and ready to go. Now I'm already down to 4. With the sensing units done, anytime someone orders a kit, that's when I assemble the harness. So the kits go out along with the sensing unit. You get a harness just depending on what pump you're running, whether it be a mechanical engine-driven pump or an electric pump. That dictates what harness a person gets. But that's also part of the job. They just don't get built until the order's placed for the actual return to center kit. I don't do anything as far as auto center stuff. That's just something I did on my own personal rig just to try it. All of mine are just return to center, so you have to push and hold the button to make it work. There's several other companies that make several different variations. I just do mine kind of in the rock crawler niche and the auto center. It's not something that's critical for what most of those guys are doing. So I just kind of stay out of everybody else's business as far as the auto center part goes. Just try and offer a super clean, simple, reliable kit at a decent price. With the return to center parts done and a couple orders shipped out, I was able to get back on this thing. And that included painting the hood and building a couple cool aluminum headlights. Painting the hood was pretty straightforward. It's a race weight fiberglass hood from AutoFab. The quality is really good and the fit wasn't too bad at all. So I simply knocked the shine off the gel coat, sealed it, base coat, clear coat, done is done. These corners here were kind of being lazy, kind of wanting to flop out a little bit. And I didn't want to use like a Zeus fastener or bolt it here, just in case that thing needs to move around. You know, this truck, the plan is to jump it and really kind of beat on it. So any hard fastening would be pretty rough. So what I did was I actually bonded a powder coated steel plate in the corner here and then built an aluminum bracket that bolts to the pinch weld on the firewall that has a magnet on it. So that bracket there, as you can see, the holes are slotted. So now I can adjust where that hood lines up with the cowl and not have a hard mounting point. If it wants to flop around or move around, it can do so. Normally it wanted to sit something like that. The headlights were a different deal altogether. My original plan was to just buy the sticker headlights and stick them on a piece of aluminum, glue them to the headlight bezel and call them done. But I couldn't find any 5x7 sticker headlights. So I just engraved the headlight pattern on the aluminum itself. Get a bumper on it and these turn signal lights when they come in. The front end will be getting pretty close. I think it's about time to put some big tires back on this thing. I'm gonna go ahead and wrap this video up here. Really happy with how this thing's looking, sitting at ride height with the big tires on it. More and more body work on it. I did get the front bumper installed. Some of the bed mounting brackets are in place now. It's a part of the front bedside mounts. That little cage around the engine is mostly for mud and waterproofing. Some Lexan panels will bolt to those tabs there. These brackets here hopefully will go into powder coat this week. Eventually I'd like to build some aluminum ones, but for now these will do. Hang the bedsides on it one more time before I commit to bodywork and paint. Get those in color. But it's coming along. As always, thanks for watching. Have a good one.